Have you ever really looked at an ice cube floating in a glass of water? I mean, really thought about it? It's something we see every day. But what if I told you that this simple act of floating is one of the most unusual and, frankly, one of the most important things happening on our planet? Let's get into why. So the question seems almost childishly simple, right? Why does a simple ice cube float in water? It's just something we accept as normal. But the answer to that question reveals a deep secret about water itself. A secret that, it turns out, makes all life on Earth possible. Because what looks completely and totally normal to us is, from a scientific point of view, a massive exception to the rules. Water breaks a fundamental law of the physical world. And this one little exception has enormous consequences for all of us. To really get it, we first need to appreciate just how bizarre water's behavior truly is. It pretty much operates under a different set of rules than almost everything else in the universe. Take a look at this. You can see a really clear pattern here. For just about every substance you can think of, like metal or rock or even wax, the solid form is heavier, it's denser, and it sinks in its own liquid. But water, as you can see, is the odd one out. Solid water, ice, floats. The general rule in physics is pretty straightforward. When you cool something down, its particles slow down, they bunch up closer together, and the whole thing becomes denser. Water is the most famous exception to this rule. So, to understand why ice floats, we really only need to look at one simple but crucial concept in physics. And that concept is density. It sounds technical, but it's not. All it means is how much stuff, mass, is crammed into a certain amount of space. If something is less dense than the liquid it's in, it'll float. And if it's more dense, it'll sink. Simple as that. This chart shows you the key difference at a glance. Ice is about 8% less dense than liquid water. And that right there, that's why it floats. Now, an 8% difference might not sound like a lot, but it is everything. This slight drop in density is the entire reason ice floats. But this just brings up a new question, doesn't it? Why does water become less dense when it freezes? Well, for that answer, we have to look much, much closer. The real answer lies hidden in the geometry of the water molecule itself. So let's zoom in, way down to the molecular level and see what's actually going on. So every water molecule, H₂O, has one oxygen atom and two hydrogen atoms. The important thing is its shape. It forms this bent V shape. And because of that shape, it has a slight electrical imbalance. One side is a little bit positive, and the other is a little bit negative. This polarity makes the positive side of one molecule attract the negative side of another, creating a special connection we call a hydrogen bond. And here's where it all comes together. In liquid water, the molecules are like a disorganized crowd at a party. They're all packed in close, and those hydrogen bonds are constantly forming and breaking, letting them slide all over each other. But in ice, everything changes. The molecules lock into a very organized, rigid crystal structure that actually forces them to be farther apart from each other. Let's just walk through that process. As water gets colder, its molecules slow right down. This gives those hydrogen bonds a chance to become stronger and more stable. Eventually, they slow down so much that they lock into this fixed, repeating geometric pattern. And this rigid pattern, this is the key. It creates little pockets of empty space all throughout the ice crystal. And those empty spaces? That's the whole secret. You have more space for the exact same amount of stuff, and that means you have lower density. This is why water expands when it freezes, enough to burst a pipe or crack a rock, and ultimately it's why ice is less dense than the water it's floating in. Here's another weird thing that happens because of this. Water is actually at its most dense at 4 degrees Celsius, so just above its freezing point. As it cools even further, from 4 degrees down to 0, it actually starts expanding and becoming less dense as those crystal structures begin to form. Truly strange stuff. Okay, so a water molecule's weird shape makes ice less dense, which makes it float. Neat science trick. But why does this one simple fact matter so much? Well, the consequences are nothing short of planetary. Let's just do a quick thought experiment. What would our world actually look like if water followed the rules? What if ice, like solid rock or solid metal, just sank? The results would be absolutely catastrophic. Lakes and oceans would freeze from the bottom up. Ice would form on the surface, sink, and just pile up on the seafloor. Year after year, more ice would sink until whole oceans were frozen solid from the bottom. aquatic ecosystems would totally collapse. Our global climate would be thrown into chaos. And frankly, life as we know it would have had a very, very hard time ever getting started. But because ice floats, it creates this incredible, protective, insulating blanket on the surface of our lakes and oceans. This layer shields the liquid water below from the freezing cold air above, and that allows fish and all the other aquatic life to survive the winter in the water underneath. And this really says it all. What looks like a boring, insignificant detail in your glass of water isn't boring at all. It's one of the most fundamental and important properties in all of nature. So the next time you drop an ice cube into a drink, just take a moment and watch it. You're not just seeing a piece of ice float. You're actually witnessing the tiny molecular quirk that prevents our planet from being a frozen, hostile world and allows all of this life to thrive.